application of differentiation. Number one, application of differentiation. Number one. Rectilinear motion. Application of differentiation. Number one, rectilinear motion. Number one, rectilinear motion. Given distance slash displacement. Given distance slash displacement as a function of time. Given distance slash displacement as a function of time, that is s of t, given distance slash displacement as a function of time, that is s dt. Recall that I said given distance slash displacement as a function of time. Recall that velocity is the rate of change of displacement. Recall that velocity is the rate of change of displacement. Now listen, these are complete concepts. We said S here represents two things. For this concept here, there's a difference between distance and displacement. But for the concept here, we assume that they are the same, right? They are the same. So now, in this case now, I'm saying that velocity is what? The rate of change of what the displacement. So I'm saying that v of t is equal to what the h over dt. The rate of change of what? Displacement over the time. That's for the second concept. So I said, given what distance like displacement as what the function of time, recall that velocity is what? The rate of change of what? Displacement with time. Also recall that acceleration is the rate of change of velocity. Note that acceleration is the rate of change of velocity. So that becomes what the v over the t. Rate of change of what? Velocity with time, right? Whenever you hear the word rate of change, it simply means a parameter is changing with respect to time. If I say rate of change, it means that something is what? Changing with what? Respect to time. That's all. If I say rate of change of velocity, it simply means what? Velocity is what? Changing with respect to time. That's the concept. So whenever you get the word rate of change, it simply means a parameter changing with respect to time, right? That's the concept. If that comes to v over t. In other words, if I write this one in terms of the s over the t becomes the squared x over the t squared. So if I write this one here in terms of this, it becomes the squared x over the t squared. I'll put this to you. Now. Should we proceed? Alright, we said something here. We said that x is what? Distance or what there? Or displacement. We also said that, recall that velocity. We said velocity is what? The rate of change of what? Displacement is what? Time. So we are saying that d over dt means what? Rate of change of which parameter? Of distance. So I'm saying that velocity is what? Rate of change of what? Distance. That becomes d over dt. D over dt means what? Rate of change of which parameter? Of distance. So d times x becomes what? The x over d times dt becomes what? The dt here. Because I have this over dt here. Of course, we said acceleration is what? Rate of change of what? Velocity. That becomes d over dt, which is rate of change of the parameter of velocity. Of course, if I recall that we just said velocity, this man here, is equal to what? The s over the t. That becomes the s over the t. In other words, A can be written as acceleration can be written as what? D over dt all into what there? Ds over dt. I have this. Of course, d times the x because what there? The squared x all over dt times the t because what there? The t squared. As I have this. Yeah. I have this. Any question? So just so that you can remember that the learning rate of change, it simply means a parameter changing what? Respect to time. That's the concept. Alright, from here, now, here's what you need to note. If you are given velocity, if you are given distance in the question, to find velocity, differentiate once. Note, if you are given distance in the question, to find velocity, differentiate once. To find acceleration, differentiate twice. I'm saying that if you are given a question, you are given distance in that question, to get velocity, differentiate once. To get acceleration, differentiate twice. That's the concept. So note that if you are given distance from the question, to get velocity, differentiate once. To get acceleration, differentiate twice. Sample problem. Example 1. Example 1. Sample problem. Alright. Example 1. Put down. The motion of a particle from O means origin. The motion of a particle from O is described by the equation. I'm saying that the motion of a particle from O, I said that O means what? The origin. Is described by the equation so I say that the motion of a particle from O is described by the equation this, where S is the distance in meter, where S is the distance in meter, and T is time in seconds, where S is distance in meter and T time in seconds. Number 1, find I. Find the velocity and acceleration of the body after 2 seconds. The velocity and acceleration of the body after 2 seconds. That's the question 1. Question 2 says the acceleration of the particle when it is momentarily at rest. The first one says the velocity and acceleration of the body after 2 seconds. Next up, the second question says the acceleration of the particle when it is momentarily at rest. Alright, let's solve the question together. First, from the question, I'm given this equation, right? So I'm going to find find the velocity and the acceleration. Recall I said if you are given distance, to get velocity, what do you do? Differentiate once. To get acceleration, what do you do? Differentiate twice. In that case, let's get velocity equation and acceleration equation. So the velocity equation becomes, we said for velocity, V is equal to what ds over what dt, right? In other words, for writing sake, I can rewrite velocity as saying that V is equal to d over dt of what of distance, right? So I want to get velocity. Only I will differentiate this man once, right? In other words, V is now equal to d over dt of x. What's x? That becomes 2 over 3 t cubed minus 17 over 2 t squared, next up, plus 21 t. I'm here. Alright, let's differentiate this one here. To differentiate this one, I'll have that v is now equal to, we said the idea was what? Multiply by the power and what? Subtract by the power. We discussed that in our initial class. So we'll have that 3 times 2 over 3, 6 over 3 minus 1. I'm done with this. Next up, minus, I have 2 times 17 over 2, 6 over 2 minus 1. I'm done here. Finally, if I have 2t, so 21t. What's my answer? 21. That's all. Alright, let me simplify this one more better. I have that v is equal to 3 cancel 3 here. I'm going to go there. 2 t to the power there, 2. Right? Next up, minus I have what there? 17t. Finally, plus 21. This becomes what? My velocity equation. Don't forget, we don't say what? Find what? Velocity and acceleration after what there? After 2 seconds. So I've got my what? Velocity equation. Alright, let's get the acceleration equation. For acceleration equation, we said to get acceleration, what if they differentiate twice? In that case, I will differentiate for the gain. So recall that we said for acceleration, A is equal to what the dv over dt. In other words, I'll have that A is equal to d of dt of which parameter? Of v. Of course, what's v? V is everything here, right? Of course, v is what? Everything here. Alright, of course, v is what? Everything here. So putting all this value here. So I'll have that acceleration is equal to d of what then? Of dt into what v? I have what? 2t squared. Next up, minus 17t. Next up, plus 21. I'm done. Alright, let's differentiate this one here again. I have that acceleration becomes what there? This becomes 2 times 2t to the power 2 minus 1. Alright, next up, minus, if I release 17t, I have what there? 17, that's all. Finally, my acceleration equation becomes 4t minus 17. So I've gotten what? The velocity equation and what the acceleration equation. So, yes, this was the original question, distance. So to get the velocity, we do what? Differentiate once, I have this. Acceleration what there? Differentiate twice. So this one, when I get this one again, I'll have this. So I'm simply what? Differentiate this one twice. I'm given distance, to say distance. To get velocity, differentiate once, I'll have this. Sorry, this, I'll have this. To get acceleration, what there? Differentiate twice. You know that what? Yes, this distance now. I connected this to this one, and I still differentiate it. I have this one. So we have what? The velocity equation and what the acceleration equation. But the question says what? Find what the velocity equation and what? Acceleration equation at 2 seconds. After seconds. So my task says that it's quite simple. I will recall my velocity equation and put 2 seconds there. What is first? It was that I'm given that time. You know, what is x? What is x? Distance in what? In meter. So for the when it comes to rectilinear motion, they'll give you the definition of each parameter. So for t is what? Time in seconds. From the question, we're giving t is what? What's t in the question? 2 seconds. What if that 2 seconds was let's say 2 minutes? You what? You convert to what? Seconds. So in this case now, it's what? It's in seconds already. So recall that what is the best equation? We said at 2 seconds, what best equation? V is equal to what there? 2t squared. Next up, minus 17t plus 21. Sorry. Alright, put in t. I have that v is equal to 2 into 2 squared minus 17 into 2 plus 21. Alright, let's simplify this. I have that v is equal to 2 into 4. Next up, what must I have? 34 plus 21. Please, what's my answer, please? I have that 8 minus 34 plus 21. Please give an answer, please. This is what the minus 5. In what SI unit? Meter per second, please. Velocity is what? Meter per second. Acceleration is what then? Meter per second. Because now, in some cases, you'll be asked what? Describe your answer. Hence, in this case, that this is what? Moving backward. This velocity was moving backward. Those are negative. Let's get acceleration and let's see if acceleration will be positive or negative. No, that when acceleration is positive, is what is accelerating. What is increasing? When it's negative, what is decreasing or what is decelerating. So let's find for velocity, acceleration equation. For acceleration, so don't forget that when it comes to rectilinear motion, to get velocity, differentiate once. To get what's that? Acceleration, differentiate twice. Alright, for acceleration equation, at 2 seconds, what is acceleration? Acceleration is equal to what? 40 minus 17. 40 minus what there? 17. Alright, acceleration becomes what? 4 into 2 minus 17. Please give value, please. Am I correct? Yes. Minus 1. Yes. Am I correct? So this simply means acceleration is what? Is descending, retarding, right? So this becomes what? A negative minus 9. Alright, thank you. Minus 9. Of course, motion is what? Is what? Descending. Right? So acceleration is what? Descending in this case. What's is that the question? What's B? What's B? What's B?